In this video we'll continue making the speeder handle for the mini milling vise, and we've looked at a few other ways to go about this in the previous videos, and this time I'll show you yet another method. We'll make one out of aluminum but without using a rotary table or the digital readouts. This time we're going to make a base out of poplar. Poplar is one of my favorite woods to work with. It's dimensionally stable, so even if you store it in a garage or somewhere that may have changes in humidity, it's much less likely to warp than a lot of other woods that you would commonly use. And it's kind of like somewhere between a hardwood and a softwood, but it's less expensive than oak and cherry and many of the other hardwoods, but it's a lot nicer to work with than pine or any of the other softwoods that you find. For one thing, it doesn't have any sap, and so it's usually very clean. So it's kind of my go-to wood around the shop, and I use it for many things. For example, all these end boards here on the ends of my workbenches are made from poplar. We want to mill out a hex in this handle, or at least ultimately that's what we want to do. But as before, we'll probably just use a test piece initially. So instead of a rotary table, we're going to use this 3.5 by 3.5 inch piece of poplar. I'll use one of these 3/4 inch diameter nuts, and we'll glue that on here, and this will be our indexing mechanism to get our 6-sided hex hole. We want to use this wood baseboard as a platform to hold our workpiece, and we need a center of rotation. As we saw before, when we rotate the work around, we need the workpiece to stay fixed in place and directly aligned under the spindle of the mill, so that our hex comes out even all the way around. I'm going to use a piece of 3/8 inch diameter drill rod as our index pin, and we'll drill and ream a 3/8 inch diameter hole in the center of the wood here. Now this wood block is 3.5 by 3.5, and the capacity of this vise is just 3 inches, so I can't hold it directly. So I'm going to use an accessory that I made some time ago. You may have seen in some of my other videos. This accessory is just a little mini drilling table, and it has a bar here that's aligned carefully with the edges of this. So when this is gripped in the vise, and if the vise is aligned with the table, then this plate will also be aligned with the table, and this back reference edge here is aligned with the table. So if you just put this in the vise, clamp it in there, and I'm using my little speeder handle here, which we've made as a demo in the earlier video. Works pretty well. With this little auxiliary table clamped in place, I can now clamp my workpiece, this block of wood, and I'm going to do it over in this L-shaped cutout here, so that the center hole of the wood block is in this cutout area, and the drill will pass down without having to go through the base of the table here. If you're using a setup like this, you want to make sure your drill bit is going to clear the edges of your table here before you drill that. You've probably seen a tool like this in some of my videos, or maybe not, but these are called spuds, and you just take some drill rod, typically this is 3/8 inch drill rod, and turn it on the lathe using a 30-degree angle setting on the lathe, and that gives you a 60-degree included angle at the tip. These are real handy for finding centers and doing a lot of other things, but I'll show you we're going to use it here probably more than once before we're all done. But I'll put it in the chuck initially, and we'll use that just to line up this part of the board here under the spindle, and taking advantage of the power feed. Okay, now I'm going to lock the table down in the X and Y axes so that it doesn't move as we're drilling. I want the center of my workpiece to be lined up with the center of the nut, because if they're not lined up carefully and accurately, then the hex is going to come out off center or wobbly or something with respect to the handle. So that's what this alignment pin will be used for, is to make sure the various pieces are lined up properly. So I'm first going to drill the hole out with a 23/64, and that's just 1/64 smaller than 3/8. and then we'll use a reamer to ream the hole to 3/8. You don't typically use reamers in wood, or at least not the type of reamer that I'm going to use. And I don't know whether it's bad for the reamer, but it's probably not great for it. So it's an operation I wouldn't want to do frequently, but I think, you know, the wood's pretty soft, and as long as you're careful not to burn up the reamer, it's probably okay. This is one of those situations where, depending on the type of mini mill that you have, you could be limited on headroom if you're using a long so-called jobber style drill. These are the standard drills you usually find at Lowe's or Home Depot or Harbor Freight for that matter. And as you probably know, if you have a mini mill, it doesn't take much to use up all the space between the head and the table, and especially when you have a stack of stuff like I have here. One solution to that is to use a shorter drill. I've talked about this in other videos, but if you have a mini mill or a mini lathe, you may want to look into getting a set of these so-called screw machine drills. And they come in the same 29 sizes, you know, I guess 1/8 or 1/16 maybe, up to a 1/2 inch in increments of a 1/64 of an inch. But these are short, so they're typically a lot shorter than the standard size drills. So we'll select the 23/64, and I'll show you the difference. You see it's almost 2 inches shorter. So when we put that in the chuck, we have a lot more room below here to work with. If I was using the jobber length drill, rather than starting with this one, I'd probably use even a smaller size to drill the initial hole, because these long drills are sort of limber and they tend to wander off center when you drill the hole straight. So you're better off sometimes, if you need an accurately sized hole, you may want to first drill with a smaller sized drill bit and then drill it out with the final size. Sometimes you might even want to take 2 or 3 steps along the way if you're drilling a fairly large hole. But in this case, with the screw machine drill, because it's short and stiff, I can just go and drill the hole directly the size that I need. If you want to get a set of these short screw machine drills, you may have to search a bit. You can probably find them on Amazon, but I haven't confirmed that. But you won't typically find them at hardware stores or even at Harbor Freight, because they are more of a machinist specialty item. So you typically have to get them from a machine tool supply house of some sort. But try searching on Google, I'm sure you'll find them. Alright, let's go ahead and drill our hole. And now we'll ream it out to the final size. I'm going to use a reamer which is 0.375 to get an accurately sized hole. I want this drill rod pin to be a snug fit in the hole. I don't want it to be loose enough that it might drop out, because I'm going to be using it to align things. So we'll try for 0.375. If that's too tight, we can use a 0.376 reamer. Now if you don't have any reamers, which is a condition that I existed in my early days with the mill and the lathe, you can just use a 0.375 or 3/8 inch drill, and you'll probably be okay as long as you drill it out first a size smaller than that. That way you won't get an overly large hole when you drill it to the final size. But since I have the reamer, we'll use it, and then we'll see what kind of fit we get. I like to use my reamers a lot slower than I would use a drill bit of the same size. That will help prevent it from overheating. You know, wood will generate a lot of frictions. You don't want to leave it in the hole very long, or it could heat up and damage the temper on your reamer. Now, one problem with reamers is that they typically have very long shanks, and I think that's done so you can ream deep holes, but also by having a longer shank, it helps them to self-center when they go into the hole, because the shank itself can flex a little bit. But that can be a problem again when you have limited headroom like this. So if you get desperate, you can either use a drill, or you can consider cutting off the shank on your reamer to a more practical length. I've done that for some of my reamers when I just had the mini mill, and the mini lathe. Let's see if this fits in here. It probably does, but the question is, how tight is it? And it's tight enough that I think I'm gonna go up to 0.376. I don't want it to be in there like Gorilla tight. And I don't remember if I talked in one of the previous videos about so-called over-under reamers, but they are sets of reamers. You can probably buy them individually, but they typically come in sets. And they are sized 1/1000th under and 1/1000th over your typical nominal sizes. So for 3/8, the nominal size is 0.375, and in an under-over reamer set, you get a 0.3740 and a 0.3760, but no 0.3750. You first drill the whole undersize, like 1/64th undersize, and then if you want the shaft to be a press fit in the hole, use the under reamer, the 374, and if you want the shaft to be a loose fit, for example, like an axle, then you would use the over reamer, the 0.376. So in this case, I'm going to use the 0.376 because the hole is a little too tight the way it is. And of course, reamers are precision cutting tools, so you always want to store them individually in a protective tube or a plastic case like I just showed. You don't want the reamers to bang together or against anything else that might damage these very precisely formed edges. And of course the same thing is true for drill bits, which is why they come typically in cases that keep them separated. Well, let's do a test fit again on our piece of drill rod. And it's still a tight fit, snug fit, but that's okay. But I don't want to make the hole any bigger because the next larger drill size would cause it to be loose in the hole, which we don't want. So because it's tight, we may have to press it in and out using the mini mill, but I'll show you a way to do that. So now we can take this apart and remove this drilling table. If you have a transfer punch set, these are normally used for punching a hole or making a little indent in the center of a hole of a particular size when you're getting ready to drill it. So you may want to align two pieces together that both have the same size hole. You can put a transfer punch between them and then punch into the underlying piece to line the hole up. So to drive this pin in or out, I've selected a transfer punch from the set that's one size smaller than 3/8, and that would be 23/64. So that means that it can pass through the hole with clearance. So we'll just put it in the drill chuck and then line the board up here underneath it. Now we can just use the hand wheel on the mini mill to drive that in. Now to drive it out, you'll probably have to raise this up so you have clearance down below, so you'd need to stack something underneath it. Since we aren't going to use a rotary table, we'll need another method to index the workpiece. So what I'm going to do is glue this big nut onto the underside of this board. This is a 3/4 10 nut and a 3/4 10 bolt. Very handy to do repairs on your mini lathe. You can find these at Home Depot or Lowe's and probably other hardware stores if they're well stocked in the nuts and bolts department. Well, it doesn't really matter which is the top and which is the bottom, but I'm going to use the side that has the reference lines marked on it as the top. So this will be the underside and the nut will get glued onto here. So first I want to press the alignment pin through so we can align the nut and have it accurately centered around that pin. We'll use our transfer punch and just apply some force. Now one thing that happened here is we've got some splintering on the underside, and that could interfere with our gluing the nut on there. So I'm going to push that pin back through and clean that up on the sander to remove those splinters there. I've got the board raised up on the nut just loosely to give me enough clearance so I can push the pin down without hitting the bottom of the vise. I think I'm going to push the pin all the way out and use a countersink on this to clean up that hole. Alright, so I'm going to use a countersink just at very low RPMs, and we'll just touch it to the board handheld just to clean up that edge there so we don't get chips underneath the nut. We want the nut to be completely flat up against the board. I found a piece of scrap material over in the bin, and I'm going to use this just to raise the board up so I have more clearance to push the pin in and out. I'm just going to position this piece of scrap here over the vise. I'll open up the vise jaws just a little bit, and that just raises this up. Now we can bring our pin under here and push it down. I want the pin to be down about even with the top of the nut, or maybe just a little bit above. Now we want the nut to be exactly concentric with this pin so that it will be exactly concentric with the hole that we're milling on the opposite side of the board. I made this aluminum bushing on the lathe, and it is sized so that the outer diameter is just a snug fit inside of the nut, and then the inner diameter is a snug fit over our alignment pin. So now I've got the nut lined up concentric with the alignment pin, and now we'll glue it in place. It doesn't matter too much how the flats are oriented with respect to the sides of the board, but just aesthetically it's nice if you have the flats, at least two of the flats, more or less aligned, but it really doesn't make any difference, as you'll see when we start indexing with it. For my choice of glue, I could use my favorite go-to glue, which is called Quick Grip. It's available in the craft section of Walmart, and it's good for a lot of things. It's very tacky when you put it on, and it sets up quickly, and it holds tightly, but I like it because you can use some denatured alcohol to clean it off later if you need to do that. The alternative I've been using for a lot of projects recently is this Loctite Gel Control super glue, and it's kind of thick, sets up quickly, but it's easy to control because it comes out in kind of a thick bead, unlike the runny, watery type that you normally find in those little tubes. So I'm just going to run a bead along the edge here, or the bottom surface, or what will be the bottom surface. And then we'll flip that over and get our alignment bushing in place, and then we'll let that set up. In fact, it's already pretty well set up, it feels like, but we'll give that a couple of minutes to set before we go on with that. Now the bushing could come out, but I can also leave it in place. I don't know if it makes much difference one way or the other, but I was thinking if I glued the bushing in place, that would provide some extra strength for this bond that might turn out to be important later. In some of my experiments, I had problems with the nut breaking loose from the board as I was indexing with it. And of course, if that happens during the middle of the project, it kind of throws things off. So you want this nut tightly bonded. Another possibility that I thought about is taking the nut on the lathe and facing it off a little bit to provide a wider flat surface here before gluing it down. That will give you more bonding area for the glue and a tighter bond. So the whole idea of the nut, of course, is to give us a way to index this around so we can cut our 6 flats on the inner diameter of our handle. And so now our handle can go on here like this, but not quite, because we're going to drill this out to a larger size before we start milling, and it will no longer fit snugly over this alignment pin. So as we did in our earlier video, we'll use just a test piece to do our initial cutting just to make sure the technique works. So I just made up this little slug on the lathe that has the same inner diameter that our handle will have when we get ready to cut it. And it fits over here, but again, that's a loose fit, so I made yet another bushing. And this bushing fits the inner diameter of the test piece and then fits snugly over the center pin. So now we're pretty confident that the center hole in this test workpiece is concentric with the nut underneath. So as we index the nut around, our 6 flats should be concentric with the center. Well, now we need a way to hold down our workpiece so it doesn't shift during the milling operation. So the way I decided to do that is I made these strap clamps on the mini mill. These are just cut off from a length of this flat material that you can buy at Lowe's or Home Depot. They typically have a bin of raw materials. And we're going to actually use this little sheetrock screw, which works well for this application. So we'll get this set up. We'll mark a hole for our sheetrock screw, and these are just little pieces of scrap aluminum about the right thickness, and make these little strap clamps to hold our workpiece in place while we're milling. Tap that in lightly with a hammer, and that will dig it into the wood a little bit so it'll stay put while I tighten these screws down. I'll move the table over to the right to give me a little clearance to get this drill in here. I've been thinking I need to get one of those nice low-profile small drills that are now available. But this is an El Cheapo Harbor Freight, and it's worked pretty well for years, and it was low cost and has done what I needed. So I actually have several of these. I keep them around in my second shop and keep one up in the attic. And a lot of times, especially when I'm doing woodworking, I'll have 3 of these. I have one that has a drill bit for drilling a pilot hole, second one for a countersink, and a third one with a Phillips bit to drive the screw in. So they're like, when I got them, at least they were under 20 bucks each. I think around $15 each. So $45, you can have 3 of them. Well, there it is. It's not very elegant, but I think it's will hold it tight enough. And you know, compared to making something out of metal, this is probably quicker and easier for what ultimately may be a one-time job. Now I'm going to put this transfer punch back in the chuck with the flat side down, not the pointed tip, because we're just using it as a press or a press punch basically to drive that pin out. And it won't come all the way out, so I'm going to have to raise this up. I'll just use this block of scrap again so that we can drive that pin out of there. Now we should have enough clearance to drive that pin all the way out. Alright. So there we go. We've got our nut glued on here. We've got our workpiece clamped down, hopefully securely, and everything concentric with that center hole. Now you could use a wiggler or a center finder to get these aligned, but we don't really need that much accuracy here, so the spud is a quick and easy way to get the job done. And there it is. You can see, I hope you can see, let me move around here. So with just a very quick operation using the spud, we got it accurately centered under the spindle again. Well, now finally we're about ready to begin milling our test piece, and as before we'll use this little double-ended 1/8 inch end mill, and I'll put that in an end mill holder, or I might use a collet this time just to see how that compares.